RS-485 is a communication standard engineers use when they need serial data to travel reliably in real industrial environments. The core idea is that RS-485 sends data using two signal wires that carry opposite versions of the same message. That's what's called differential signaling, which simply means the receiver looks at the difference between the two wires instead of comparing one wire to ground. In practice, that matters because electrical noise from motors, VFDs, relays, or power cables often hit both wires in a similar way. When the receiver compares the two wires, most of that shared noise cancels out. That's why RS-485 is usually more stable than older single signal serial links in noisy facilities. Now, the second reason RS-485 is so common is that it can connect multiple devices on the same pair of wires. So instead of running a separate cable for every single device, you can run one cable through an area and place devices on that same line. This is commonly used for meters, sensors, remote I/O, and controllers. Protocols like Modbus RTU are often carried over RS-485 for exactly this reason. But reliability depends on the cable layout, so you want to avoid star wiring. Star wiring means every device has its own cable that runs back to one central connection point. Think like spokes on a wheel. Star wiring creates multiple branches, and those branches can cause signal interference that shows up as common timeouts or unreliable communication. For RS-485, the safer option is a single line wiring layout. A single line wiring layout is just one continuous cable path that runs past devices, with devices connected along that same path. So if your system needs longer distance, better noise resistance, and multiple devices on one serial network, RS-485 is often the right foundation. In our next couple of videos, we'll be comparing RS-232, RS-422, and RS-485, so you can choose the right one for your next application. So make sure you subscribe and like this video so you don't miss out on the next one.